right. Ms. Sherbinsky, are you ready to do synthesis reactions?
I am ready to synthesize.
All right. We got, well, for my packet, I don't know where it is in yours, Unit 7, Chemical Reactions, Day 2, Synthesis Reactions.
Yep, ours is Unit 5, Synthesis Reactions. So Mr. Roy and I are going to do this series of reactions for you so you guys can see what these labs look like since you can't actually be in the laboratory with us.
Make sure you read the background information and procedures so you know what's going on in the experiments. We will be following the directions, right?
Yes.
Yeah, of course.
We have read the lab already.
Yeah. We even wrote the lab, I think. So, first reaction is magnesium and oxygen. So, where did I put those? Oh, there they are.
Magnesium's here.
Yeah. All right, so we got our, how long are these supposed to be? Does that look like the right length?
Yep.
So, now, because this is a video, you actually do
3
get to watch.
centimeters.
Because usually you'd have to look to the side of it because it's bright enough to cause some potential eye damage. But usually people look at it anyway.
What he's trying to say is don't look directly at it.
Well, through the modern use of technology, you know, I mean, you can't capture how bright it is probably in the video. Are we going to be able to see this okay? Yeah. All right. So this is supposed to be magnesium with oxygen.
And the oxygen's coming from the air.
As long as I can get it warm enough. There we go. And I'm holding it over this ceramic mat because I don't want to. Yeah, we could do it again. We got a second one. Don't want it to crack the table, the countertop.
It wouldn't crack the countertop.
Oh, it can. It gets hot enough. That kind of burnt in a weird spot. Alright, so make sure you make observations where you're supposed to. Here. In the packets. Alright, so that was reaction 1. That one's way more fun to do in real life.
Right. So underneath the number 1, make sure you write down what you just saw from the Bunsen burner, which hopefully you can see close enough, the color of the flame, and what you saw the magnesium do.
Great. All right, should we move on to reaction 2?
Yes.
I already took the liberty to measure 25 milliliters of lime water. It's the LW.
Okay, so here's our lime water.
And then, what do we need? We need the deflagellation spoon.
Yep.
Combustion spoon, and we need the carbon.
Right, the charcoal.
Awesome. Can you carbon me up?
Carbon you up.
Look at that. Carbon chunks.
So he's going to heat that up.
I don't really like this Bunsen burner right now.
So Mr. Roy is heating the carbon up in the combustion spoon and the outer part of the Bunsen burner until the carbon itself starts to glow.
What do we have? Where'd the glass plate go?
And then I saw it, you had it here a second ago.
Is it under?
Right here, here's the glass plate. So we're going to use a glass plate. Once it's heated up, we're going to lower it into the Erlenmeyer flask. But we are not going to touch the lime water.
All right, that looks pretty hot.
Right. So can you guys see how we're lowering it into the flask, but it's not actually touching the water, so it's down close. I don't know if the computer screens are close enough.
It's hard to tell from this.
Yeah.
And the angle of this is so bad, actually. I should use a bigger flask.
Right. So he let the combustion spoon get almost red hot for the carbon. We're trying to make sure that it's covered as much as you can.
Looks like the lime water is changing. I'll have to hold it up to the camera so they can get a better look at that.
Right. So after a minute or two, we're going to remove the combustion spoon from the flask. And then we're going to put the carbon under a stream of tap water. And then we're going to shake it for a minute.
All right, that's probably been about a minute.
Ooh.
There. All right. It's out. I'm collecting all my solid waste over here. Oh yeah, that definitely worked. Awesome.
Okay. You see? We'll see. Okay, so describe what the lime water looks like. Any changes you saw? Write that down in your observations under the second lab.
Great. Yep, that was reaction 2. Carbon and oxygen. All right, so reaction 3, we need the water flask this time. So this one seems pretty similar to the carbon one, except we're using sulfur. And sulfur turns into a sticky mess. So we're going to line the spoon this time with a little bit of ceramic paper, just so hopefully we can eventually clean this up. That's our plan anyway. So we'll get the sulfur out here so we can scoop some of that. Do you want to scoop some sulfur? Oh, is this a brand new? Might be a brand new container. Good thing about doing these labs with just us is, man, we don't use much material. Although the lab is a mess anyway, which is probably my fault. There we go. You guys know what sulfur looks like, right? Oops. Got it on your keypad.
Thanks.
You're welcome. Alright, this one's the trickiest one, isn't it? I think.
Yeah.
We could very well poison ourselves, but this could be a cure to the coronavirus.
So again, we're going to heat the combustion spoon. And once it ignites...
Oop, we're ignited.
Wow, you really, picked small aromar for us, didn't you?
Why did I... Yeah, can you cover that with a glass plate? Oh, gosh. That's really stinky. I don't know if you saw the flame or not. It's actually really hard to see the burning sulfur, but you can definitely smell it. What do you think? Like cross between egg farts and burnout?
And a swamp.
Swamp, yeah. This one I definitely gonna want to extinguish. Well, it might have put itself out. I don't know. Is it still burning? I see smoke. That looks good.
You ready?
Yep. 3, 2, 1. Huh. In the lab, you're supposed to smell that. Be glad you don't have to, because it is stinky. All right, do you want to show them the oh gosh, the gas we created? Maybe they can see it. So in this reaction, we're supposed to save the products for reaction 4.
Right.
But we do have, it looks like smoke, I guess. I don't know.
And it stinks.
And it stinks real bad.
So then we're going to test it with litmus paper.
Yep. So we got blue and red litmus paper here. We're going to drop those in after we shake it into the water. So this reaction is the gas and the water are going to mix together. Hopefully it will absorb all that putrid smelling stuff.
So that would have been one of your observations, is how stinky it is.
And it is stinky. So hopefully we've talked about some of the gas tests already. We did lime water earlier, which is a test for a specific thing. And here we have the red and blue litmus paper, but they're both pinkish red now.
Hopefully you can see that.
So the blue changed red.
Hopefully you can see that. It's kind of sticking to this eye.
So
now
we made
it's absorbed the gas.
Good.
So the blue litmus paper changed red, which indicates that something was produced. And the lime water turned cloudy.
I'm going to steal this for the next one. Is this the last one?
25 milliliters of water.
Yep, that's more like 50, but yeah, it's pretty good. Got a little bit extra sulfur there. Alright, for the last one, all we need to do is add 1 scupula load of this, what is it, calcium oxide, to our water. I don't know if you can see that. Yummy. Yep. I want to get those. We're supposed to shake that in.
Crap, that's fine.
You'll have to call back later.
Oh, that's the doctor.
Oh, that's the doctor? Alright. So we got that stirred in there. It's pretty disgusting looking. We're going to add the litmus paper. We have a red one and a blue one. Stir that up. See if we get any change there. And, well, I don't know if you can see that because it's pretty cloudy in there, but both the strips are blue now. Oh boy, can I get it to stick to the side? Come on. I have to pour the liquid out. Oh, there you go. Okay, there's the red one. You can see the red one hopefully is changing color on the side as it absorbs the liquid. So it's going from from red to blue. red to blue. So in the other reaction, we had them both change to red. And now in this reaction, we have them both changing to blue. Well, one was blue originally, and now the red strip is changing blue. So blue and red. So we did make two different products there. So anyway, from those experiences, from those lab experiences and your observations, try to make predictions about what is created out of those labs. Remember, they are synthesis reactions, so the synthesis reactions come together to make one product. So try to formulate a reaction prediction for those, and later on we'll get into some of the details of the reactions and how they work.